Okay. Hello, everyone. Thanks for taking the time out of your day to join us for our webinar. Today's topic, how to eliminate slow test cycles for developers, will be led by Launchable's founder and CEO, Harpreet Singh. In this webinar, he'll talk about how data and machine learning can help teams deliver smarter by testing what matters. Please save your questions for the Q&A section at the end of the webinar, and we'll also have a poll for the audience during the key problem segment, as well as a survey for you to fill out after the session. Thanks. Over to you, Harpreet.
Thanks, Drew. Good morning, everybody. Sure, a lot of us as developers or have developers on our team have, heard this thing. It's like, there's a small change. Why do I need to run all the tests? I've heard this numerous times. And the inspiration for Launchable came in from one such quote. And in this presentation today, I'll talk about how Launchable is helps us solve this problem. So the agenda here is we'll talk about Launchable, what we do. We'll jump into a case study. We've been working with the Silicon Valley Icon and helping them. We'll talk about what we've been able to deliver for them. That should spark enough interest that you want to understand what's actually happening under the hood. How can I get machine learning on push button for testing? We'll talk about that at that point. And once you have that perspective, we'll just do a quick wrap up by talking about a car company who's using this, our tech. And I'll end up with talking about partnering with us and what that means today. And then we'll have head into the Q&A section. The presentation today is sort of made for primarily engineering leaders. And I think of engineering leaders as folks who are building a shipyard. And your focus is how do I get more ships out on time? And that's the hat that you're wearing, and we help in that. Now, if you're a developer, don't lose hope. The technology deep dive section is fairly interesting. Soldier through the case study section, you'll get an understanding of what we do, and then you'll understand how the technology works. So with that, I'll head into about the Launchable section. So Launchable started by me and my friend Kosuke. We partnered since our days at JavaSoft and Sun Microsystems, where he was building Jenkins, and I thought this an opportunity to build a business around this. Subsequently, we partnered at a company called CloudBees, where we built the DevOps business together. And more recently, I was at Atlassian as the head of Bitbucket. The reason why we got together is both of us have talked to hundreds, maybe if not thousands of companies over the years, and we've seen them struggle trying to deliver software and trying to deliver software faster at high quality. And we've been talking about DevOps before DevOps was a term, and we see companies going through DevOps transformations, digital transformation, and so on. But we felt like there was something missing. It's like you walk into the doctor and you tell the doctor that I'm kind of not feeling too well, and the doctor tells you like, go fix your diet, go run 3 miles a day or so on. And that's absolutely the right advice. However, your head's really hurting, or you need that vaccine fast, you need that medication fast, and that's not available. And that's what happens with a lot of organizations. They go on these multi-months, maybe multi-year transformations to deliver things fast, and the results aren't fast enough. And we wanted to sort of go in and wear the hat of being a doctor and coming in and enabling things very quickly. So that's why we started the company. And as we looked at the entire SDLC pipeline, we realized that the biggest component that gets in the ways of folks is around testing. And we felt that there's an opportunity here to actually look at the problem in new ways and solve them in new ways and make an impact to teams. So what you hear today is sort of the outcome of that thinking that me and Kosuke have had for the last couple of years. So what do we do? right? I've already talked about we are trying to help teams move faster. So our focus is on reducing, software delivery cycle times. We think we can bring in a massive reduction in testing times, maybe about 30 to 90% reduction in those times. And our focus and our goal has always been to reduce that feedback loop that goes to developers and make it near instantaneous. We want to do this by eliminating risks. So one of the things, and what I mean by that is tests grow over time, right? You add more tests, and you're always writing more tests. When you add more tests, when there's enough tests, you just can't run them all for every commit. So you push some of them right. And what has happened in that case by pushing some of the tests right is you've pushed your risk right. And so you, as a developer, you push some changes in, and maybe your nightly is coming in, or maybe you get your integration test to come in tomorrow morning, and you find that there's a problem. So you've effectively pushed that risk right. It's too late, and that causes a lot of stress. So we want to bring that left, and we want to do that by shifting tests left, and we want to do this by almost a zero cost to shifting left. So how do we do it? Very simply, we identify and run tests that matter first. That's simply it. The way I think about this is it's finding the right tests to run based on the changes that are coming in. Is sort of finding this needle in a haystack, right? In organizations, there's anecdotal knowledge that some tests matter more. Some folks know this more than others, but you can never really go down to like, here's the change and here's the tests that matter, right? And we are pretty good at finding that needle in the haystack, and we show that through the case study. So that's what we do. And the other aspect that sort of we think about is we're trying to help engineering teams, of course, all right, developers to move faster, but we are also trying to help engineering leaders, right? There's a picture of a good friend of mine at a company event where we were asked to build this cardboard boat. And the problem with the cardboard board is like it barely stays afloat. There's not enough things. There's not the right technology. You plug in one hole, another one opens, and that's how I think engineering leaders feel today, right? There are lots of tests going on. If there's something goes wrong in the test, it adds to the time, delay in delivering stuff, right? You analyze the stuff, you sort of come back, fix it, and you push it again, and maybe you have the problem again. Or root cause analysis is hard. So every time you cannot deliver on time, it takes your credibility takes a dent, right? And in that worldview, where you're just keeping the cardboard board afloat, what tends to happen is you're not able to provide the latest technology, the best software tools to your developers to go do their jobs well, right? And then we are asking these developers to work on like a pipeline that's maybe 5 or 7 years old with tech stack that's 5 or 7 years old, and then ask them to perform at unicorn levels, which is just not fair. And that means developers are unhappy, right? So that's what we wanted to come in and do, is bring new technology at the flip of a switch to these teams. So as we looked at this problem, this domain around testing, here are the 5 key problems that we think that we can go and address. And at this point, I'll just run a poll in the background such that you can answer if these resonate with you. So problem 1 is this notion of slow test feedback. And my canonical example here is, let's say you have 1,000 tests, you run those 1,000 tests, and test 900 failed. And at that point, the question would be, why did I run the first 899? And today what ends up happening is all these 1,000 need to run before the developer actually gets feedback. So that's a long feedback delay. In bigger teams, when lots of developers across lots of time zones are trying to push things in, if something breaks, some poor bloke who wears the QA hat, maybe a QA team or the dev person on the team looking into this, needs to go figure out who's made these changes. And that takes time. The third one is this notion around what test to run. I've talked about sort of the needle in the haystack problem. the question, this manifests in multiple ways, right? One of them is like, hey, I have a patch that needs to really, really go out today. I have like 30 minutes to test. Can you give me all the tests that give me a certain confidence in that 30 minutes, right? The highest confidence. So we help to do that. Then there's this notion of flakiness of tests. Tests grow over time. Some tests don't perform well. And what ends up happening is developers start losing trust in tests. And that's a very hard place to sort of dig yourself out of. The last bit is around QA infrastructure costs. And in this case, going back to the canonical example, again, you had the 900 test fail. The question here is, why did we sign a check to Amazon to run the first 899, right? So we're just spending money because the real signal that has come to us has been around QA infrastructure costs. So these are the problems that we are sort of walking down the path to addressing. So we think of this as a roadmap. So thank you for everyone who's actually filled in the poll. I'm going to end it. The result here is that about 80% of you think slow test feedback is a challenge. And the second win there is what test to run, which is at 55%. So that's what we are trying to solve. Let's just get into the first case study on how we do that. So we're talking to a Silicon Valley icon here. They're sort of on the leading edge of delivering software. The entire world looks at them on the best practices to deliver software. As we're talking to them, they have like a few challenges in this division. And this division is about 1,200 people large, right? The technical issues has been around feedback delay. Their cycle times are about 1 to 2 days at a minimum, right? It's a painful end-to-end process, right? They think they have testing bandwidth issues. So they are using new technology, they're using VMs, containers, and so on and so forth, but they think that there is a queuing issue when they talk to us. With 1,200 developers, there's a QA triaging issues. There are multiple sort of threads that are running and multiple branches that are running that people are delivering on. And this is a Q team that's into this. On the business side of the house, the VP of engineering shared sort of this developer productivity issue. Now, usually developers think of developer productivity as something negative, but the angle that these guys are coming from is if you have these long cycle times, it means that the developers are frustrated. They can't get their jobs sort of done faster. They are context switching between things, and we all know that context switching is not helpful. And when they become sort of frustrated and they're working on technologies that are not letting them move as fast as they want, there is corresponding attrition. So much so that in their case that they have elevated sort of employee satisfaction and developer productivity as a top level management goal. And it has been their goal for the last 3 years, and they're making progress on it, but not fast enough, right? And so that's something that they wanted to address. Now, we asked them what success would look like. And a team of about 1,200 people, even if you're able to give them like 30 minutes to an hour back per day, that would be an impactful number for them. So that's what they had in their mind. And so what we've done with this group is actually we piloting with a small team, quote unquote small, which is 50 engineers. It builds a sort of product on top of the base platform. It's a packaged software, as well as there's some SaaS component to it. So, and we've chosen a particular part of their SDLC lifecycle for this team to actually make the changes. And we chose this team because it's a sort of a lighthouse team within their organization that's using new technologies to improve things. So we set the scene for this team. They have developers who are pushing changes to get it, and then unit and integration tests run. And in their case, they're using Bazel, right, which caches tests. And that's why I think of them on leading edges, because as a leading edge team, because not too many teams are on Bazel. So they're using Bazel, and then the test results come back. It takes like couple of hours for that feedback to come in this cycle, and then they go in and change next, right? And so we chose on this part of what we call the pre-merge test to help see what impact we can bring to the table. So before I sort of go into the details of it, I'll just talk about like what we were able to show them as a result. At the top of it, we could actually come in and tell them, how much time or do their developers wait, per day, per year, and translate that into some, cost. Um, Now, this is one of my this is one of the things that I deeply care about, because in one of my past roles, we could never really determine how much it costs our organization on waiting on tests, and so we could never make the justification on spending a lot more to fix things, because eventually you look at ROI. So here in their case, you were able to come back and tell them, even for this small team, they're spending this much amount of time. And with Launchable, we could actually drive down those costs by 40%. Right? And so let's look at one level down on what that looks like. So the first thing that we've done with them is actually produce what we call a time feedback delay curve. Now, what this is on the x-axis, you have the total time it takes you to run the test. On the y-axis, you have the confidence or the regressions found. So in this case, if you look at the baseline, what the baseline actually shows you is you have about 75% of the tests, when you run them, this is the red line, you get to 90% confidence, right? So going down, you have to go through 75% tests to get to a place where you get 90% confidence. Now with us, once we actually sucked in their data, we analyzed this, we ran the machine learning algorithm on it, the model on it, we could produce this time feedback delay curve that says like, well, to get to the same 90%, you need about 20% test, right? So that's what we can do for them, right? Now, the key portion here is not just the 90% number. So the way we think about this actually is a dial that lands up towards dial that engineering can use. So if you're early on in your release cycles, or perhaps you're early on in your development phases, you may move the dial down. In this case, you could run just 2.5% tests to get 86% confidence. If you're later in the cycle, you may move the dial up. So you start getting this flexibility on where to draw the box. So that's that's what we were able to do with them. And so in their case, if you look at this, we looked at this and we said, hey, here's your test. And if you choose this 10% number, the 10% number actually ends up showing, maybe I got the earlier slide wrong. What we can get back to you is their cycle time today is about 51 minutes on that pre-merge cycle, on that SDLC part of the SDLC cycle, of which about 29 minutes is unoptimizable. This is where a build's happening, or Basil's doing some compute computation, and so we have about 22 minutes of time that we can optimize. And that time we can bring down by 40%, right? So your end-to-end time becomes 31 minutes. So you drop it from an hour to about half an hour, right? The other interesting thing that we were able to see with them is we could sort of look at their graph and say, hey, this let's look at what Basil does to your system. And so for those who don't know what Basil does, it's caching your tests and making sure that it's running the right test. So it's already pre-optimizing the test runs. So the way to read this graph is about 100% of the builds kind of run in 36 minutes. So your worst case scenario is 36 minutes. About 50% of your tests kind of come back within 25 minutes or so. This is the red line, right? So this is that's why you don't quite have, if you don't quite have Bazel and you're say perhaps running this on Maven, you'll have like a fairly static build time. But Bazel is already optimizing this such that your average case is much better than your worst case scenario. And even in this world, we could be on top of Bazel and look at an optimized test. So we are able to bring down their worst case scenarios from that 36 minutes down to 3.5 minutes, and the average down from maybe 22 minutes to 2.5 minutes. What's more interesting, as we drill down further, we could come back to them and say, hey, looks like, in your organization, in this particular team of 50 people, it takes multiple patches to get one change in, right? There's about 5 patches that need to happen to get a change in. And it takes about 6, changes per day to get, only 6 changes per day land per day, right? And that was quite interesting, right? So now if you sort of, uh, step back and look at things, it takes you about an hour to run a build, and on an average you're running, a developer is running 5 patches, 5 builds to get one change in. That's already 5 hours, so you're actually looking at multiple days in delivery time. So what we were able to tell them is like, well, the business impact we can bring in is actually, value and time saved, right? You don't no longer have to spend thousands of hours waiting on tests. You're improving your cycle time, it's reducing almost by half. That essentially means that developers don't have to do a lot of context switches, and they can just focus on a task and move on. And all this actually ends up meaning that they'll have happier developers. Hopefully, that leads to lower attrition, and there's a direct impact on satisfactions and MBOs for the team. So now that we've seen like what we were able to do for them, let's just look at sort of under the hood on how do we bring this machine learning model to testing. So one of the key things that we as a team really hone in on is this notion of test feedback delay, which is where a developer pushes some changes in, and then the tests run, and the first failure is found. We think of this first failure as this great signal where a developer can actually look at it and say like, hey, I can now move on and start doing some work. I can analyze what's gone wrong and start working on it, right? So that's the thing that we're trying to optimize for. And as we looked at this problem, we said, hey, today all tests run in some randomized order, right? And they're not optimized for a low time to this failure test feedback delay. So what can we actually reprioritize these tests based on some probability of failing? And that's actually what we've done. So what we do now is we figure out the probability of a test failing for a particular change set, right? So if you're able to do that right, what that means is we can now sort these, in some form, right? So we can now reorder these tests based on the changes that are coming in, right? So here's the test, here's my changes. We predicted the probability of failure of these tests, and then we've reordered them. And because we've reordered them, we can run the ones that have the highest probability of failing earlier on, right? So going back to that canonical example, I had 1,000 tests. 890 and 900th is the most likely to fail. We can actually come back and say, run the 900 test first, right? Simple enough. But based on the simple enough idea, you can actually start doing something more interesting things. One of them is this notion of boxing these tests in some manner or form, right? We call this an adaptive subset for a change set, right? In the adaptive subset, I could ask Launchable to box these tests based on, say, a time window that I give it. So give me all the tests that can be run in these 30 minutes that are most likely to fail. I'll get that set back. Another one would be give me all the tests that meet the 90% threshold ratio, right? So we'll give that back to you. So that's sort of what we can do on top of this. Now, how this actually works is Launchable runs as a SaaS service. So what we do is we sort of inject ourselves as part of your test runner. So if we take an example of a Java system, what happens here, let's say you're running Maven, you'll get a launchable plugin, and that plugin, a launchable Maven plugin, and that plugin, when Maven starts running tests, running a build, the plugin reaches out to Launchable Web Service and says, hey, here are the changes that have come in. What tests should I run? And then Launchable comes back with a prioritized list of that tests. And on your system, Maven continues running them. The tests, run in this specific order that Launchable has sent back. And once the tests have run, the results are sent back to the web service so that we can continue training our model. Now, what has happened for the developer here is they've just suddenly started seeing their builds run their tests run much faster. Their builds are going much faster, and they didn't quite have to do anything. This modification, somebody had to once change the build script to include, the launchable plugin in, and that's about it. So that's what we mean by sort of this push button machine learning in the hands of, folks. So what gets sent to us? So one interesting piece here is one of the reasons why we've gone down the machine learning model is that we can actually infer what changes to what test failures from like features that are fairly high level. So for example, it might be the files change, the number of lines changed, who's made the changes, the size of the changes, and so on and so forth, and your test case results. Because we aren't quite doing any static analysis, we don't quite need the source code content. We don't quite need to look through the log files and scrape the log files, and so we don't need information on sensitive data, right? And what that actually has meant for us is we are fairly tech agnostic, right? So we think of us actually sitting at the top of all test sort of runners and test suites, and we can actually learn about these relationships across languages, across front end, back end tech stack, and draw these relationships and just provide almost like a advisory service back to your test runners stuff. So that's sort of what's happening under the hood. What that actually now means is, like, once you have that kind of tech under review, the question to ask yourselves, and this I think is a homework item for you, is like, if you had this capability, what does it mean for your workflow, and how does your workflow change? Now, to seed that thinking, I'll actually walk through two specific use cases, right? Use case one is this notion of the nightly integration test, where your tests are running. Some person comes in, she checks in changes at 10 a.m. She's very diligent, and she stays, at midnight to see whether her changes have passed. And at 2 a.m., she gets feedback that tests have failed. So her sort of test feedback delay in this case is 16.2 hours. The cumulative feedback delay across the entire organization for all developers in this case is about 1,000 hours a week. So we think of this as the wasted time in this organization, right? They're spending 1,000 hours. And so that's sort of the worldview. In this case, you could use an adaptive subset, right? And change your workflow in that manner. So you still have your sort of nightly runs. They're running. They're sort of the fence that stops cattle from running, but what your adaptive subsets are running like twice an hour, right? Now, she's the same developer who comes in, pushes changes in at 10 a.m. And then the adaptive subset runs at 10 a.m. And within, in this case, within 18 minutes, she gets feedback. She has the context of the problem in her head. She can just see what the failures were and go fix that. And she can run through this loop a couple of times and hopefully gets her changes in, right? So if I go back to the Silicon Valley company, which on an average people were running 5 changes a day, it is perhaps feasible to get most of the changes in by the end of day one or at most day two, right? So there's a substantial sort of reduction in the cycle time to deliver net new features. So that's one use case. Another use case is just your smaller test harnesses, right? You're running tests, they take 45 minutes, perhaps they're unit tests. Most people that we talk to are trying to keep unit tests, in 45 minutes. So these are perhaps somewhat, they're trying to keep unit tests in 10 minutes. So perhaps this is somewhat larger. But in this case, what tends to happen is because these test harnesses are small, these test suites are small, people tend to run them multiple times a day. So this 45-minute run or 22-minute feedback delay happens multiple times a day. Now, in this case, you don't quite need to sort of have the adaptive subset. What you just want is, the reordering tagged along, and your feedback delay, reduces substantially. So you've now gone from, what was it on the previous slide, 22 minutes to about 8 minutes. And then cumulatively, the feedback delay time across your organization drops down. So that's sort of what we are able to do. Now, what's interesting for us is, as we thought about this problem, one of the things that was very clear to us is developers will understand this, right? Your builds have just started going faster. Nobody needs to tell them that their builds have gone faster. They'll see this, they'll be happier. But as engineering leaders, as org leaders, we often need to we're looking at sort of making an impact cumulatively across the organization. And how can we sort of bring in changes to the 1,200 people within the organization? And what is that impact that we've made it? And those numbers are not easily available today. So what we've done is we've actually built some of these things in. So for example, let's take the scenario. In this case, a team actually connects to us on the Launchable service, and we've continued learning about this. And at some point, we can come back with a dashboard that says, hey, your average time to first delay in this team is about 7.5 hours. Your cumulative feedback delay time is 1,300 hours. And these are the kinds of changes that are going in. Now, at some point around June 13th or 14th, where we've learned enough is where they turn the system on to actually start making, providing the feedback to the test runner on what test to run. And at that point, they will see a massive drop in the time to first time feedback delay, right? So now in this case, they've gone from 16 hours to 2.1 hours. So that's one of the things that as engineering leaders, we can kind of go in and see. Another one is around the impact on developer productivity, right? So as you get more changes in, as your cycle time reduces, you get more changes in. So the theory would be that you're actually pushing more and more changes in, and then at some point you find this new steady state for your organization. So you start seeing that as a graph within the product. Another interesting one here is the impact of an adaptive subset, right? So if you're looking at the same use case that we've talked about on nightly tests, you had some tests going on, and most of the issues that are being found in the nightly test, right? So it has this curve and shows on around June 16th, it has about 16 or 15 or 16 issues that are found. And by bringing in adaptive tests, what you find is the adaptive tests will fail much more, right? Because as I said earlier on, you're moving the risk left. So the adaptive sets will start picking the load up on identifying these risks. And the number of issues that the nightly finds, drops down at that point, right? So that's another one. And the last bit is something that we built for engineering leaders is this notion of like actually what is the cost of this feedback delay for my organization. So if If we take the cumulative feedback delay that's happening in the team, and we take that by the cost of waiting time, which is typically the cost of a developer, and they're the most expensive resources in an organization, you can come to a place where you can say, hey, it costs us, X amount of dollars per day, right? And that makes it easier to kind of go in and talk to upper management to help in more resourcing. So with that, we've dove deep into the under the hood. I'll jump back up and we'll talk about sort of this car company that we've been talking to. And it's funny when we talk to a lot of people about improving cycle times. Everybody kind of thinks about like, hey, we'll get into this continuous delivery mode and we'll spin up more resources in the cloud. Guess what? You can't really spin up a car in the cloud if you needed to test, right? So we're talking to this team, and this case study is available on our website, so I won't get into too much detail. I just provide the color around it. Their key concerns is from the tech side. This is a central, I would call a DevOps team that is helping a team, multiple teams, maybe about 100 to 200 developers in that organization. And their focus by the central team is to help these developers go faster, right? Their main issue is hardware wait time. They are building this dashboard computer, the graphics unit, and there's just so many of them, and the tech changes on them every few years, so they have to keep on sort of replenishing that hardware every few years. So their mitigation path today to improve cycle times on testing is fairly simple. Well, let's just double the budget in 2021, get more hardware. There is a team that is looking at managing and maintaining the hardware lab. This will be more work for them, but hey, guess what? Can't do much, and we'll drive that forward, right? On the business side of the house, they share the same issues, which is like this hardware units cannot be added fast enough. Slow feedback time is an issue for developers, and that shows up in a couple of escalations at the VP level, a few times a month, right? And when we talk to the developers, the developers talked about sort of they see the central DevOps team actually working very hard to drive things, but things don't move fast enough for them, right? They're because they're waiting on this hardware. So they're somewhat frustrated. So in their case, we could look at things and said like, hey, your pipeline, and we focus on a particular part of the pipeline before we go elsewhere. In that case, their pipeline looks like this in this pre-merge test scenario. It takes them some amount of time to set things up. Some amount of time waiting on the queue, and then there's some amount of time executing the test. This is fairly close to the earlier example. So it takes them about 2 hours to run these end-to-end tests. And in this scenario, the graphs looks somewhat similar with the earlier case. It takes them about 75% tests to get to 90% confidence. And then when you brought us in, we could get to that confidence level by bringing in by running 20% tests. So you can find 20% tests to get to the 90% confidence, right? So again, going back to my earlier comment on the dial is what you care about, right? You can actually move things left or right. You can, go aggressive or go, conservative, choose the right amount of tests, but they now have that flexibility to do that. And the other aspect for them, which was interesting, is because what we are able to do is they can choose a smaller set of tests and get to the same confidence. What ends up happening is the hardware actually becomes free earlier. So somebody else who's waiting on the hardware can run this test and get to the same confidence earlier, right? And so effectively what we have done for them, what we can do for them is triple their hardware capacity without actually adding new hardware, right? And they continue, what they have done is they will continue running that one sort of um, testing run after at the end of the day, such that no issues leak through the system. But what they have effectively done is actually making sure that their developers are moving much faster. So, so, and we could come back to them and say, hey, based on what we see on how quickly things are running in your system today, your team is waiting about 35,000 to 50,000 hours a year, right? And that's waste in the system. And we can actually drop that down. Again, in this case, it was 40%. So that's sort of what we've done with this car company. I'll encourage you to go on our website and read about it. Finally, I'll close this with sort of making this pitch on partnering with us. So we are looking to go GA end of fall, and we have a few spots on what we call as product advisor program. And the product advisor program is what these two companies were working with us on. And what we do here is we sort of are looking at companies where we can make an impact. So we identify a project, the tech stack, the part of the life cycle that they want to have an impact on. And once we get that, we look at the data that's coming in from them. We build a custom machine learning model for them and analyze them and come back to them with the analysis, the way I showed about these two companies. And then we present that impact analysis to them. If all things are fine, we end up sort of piloting in their environment. And along the way, we get feedback on sort of the design and UX, the ones that I've showed earlier. We get the feedback on them, right? So I'm going to make a pitch to reach out to us to actually talk to us about being a product advisor. The benefits are you get to sort of understand your environment, and you get this time feedback delay graphs and the other ones that I've showed. And then you get to partner with us. We're a good set of guys. We've been in the DevOps space for a while, so partner with us, work with us. It'll be a fun journey, and then influence the direction of the product, right, on where we should be going. And more importantly, bring in sort of this next gen technology to your teams at fairly low time cost to your teams, right? And ultimately, when we actually go GA, as a thank you, we are going to give some advisor-only pricing discounts to the teams. So to wrap up, summary is we are looking to bring in push-button machine learning to testing. We want to reduce software delivery cycle times by reducing testing times, maybe 30 to 90%. Want to bring instantaneous feedback loops to developers. We want to do all of this by reducing risk by smartly shifting tests left, and at almost zero cost to shift left. So with that, I'll call this presentation done, and we'll open up for questions.
Awesome. So Harpreet, we already have quite a few in the Q&A, and so I'll read some of those out and we can answer them to the group. And apologies, these come from an anonymous attendee, so I'm not quite sure who's asking. But the first one is, how much access to our CI or VCS history do you need? We are operating in a closed company network.
Not sure what a closed company network actually means. We are actually looking for test result data today as a product advisor program, and we are looking at your changes that have happened. So typically our ingester program, I didn't really talk about this, it sits in your environment and scrapes this data off from your CI server and sends that to us. What we do in that worldview is you get to look at the data that's about to be sent to us to make sure that, it's kosher, and then that gets sent to us, right? So again, what we really need is test results in machine readable form. So it's not very intrusive, if I have to summarize this.
Okay. The next one is, do I need to change my code base to use your tool?
No, you don't quite need to change the code base at all. Going back to my example where we had, say, a Maven plugin, what you would need to do is do sort of a minor edit on your build or your test runner on your build tool and inject a plugin that comes in from Launchable, right? And that should be it.
Okay. The next question is about slide 16. How can you know these confidence levels in advance? Is this statement then solely based on historic data? What if our development processes slightly change?
Right. So this statement is based on historic data. This graph that we've created is we've looked at changes that have happened in the past and the test results that happened in the past. Now, if your development process changes slightly, and by that, the way I think about it, perhaps you're adding new tests and so on, the machine learning algorithm the model actually learns about those. Now, how do we actually factor that in is part and parcel of being a product advisor program. So we are looking at answers that help teams. So for example, one implementation of this is you've added new tests. We just prioritize those early because it's most likely that those changes are coming in are for new changes, right? So those tests have come in for new changes.
Okay. The next one is, does your tool detect flaky tests by rerunning them? We have the problem that some tests run close to half a day, hence we can't simply rerun them.
No, we don't quite detect flaky tests by rerunning them. The algorithm actually detects them over a period of time, right? So the signals might be that, some tests just go up and down fairly regularly. And so that's something that we don't have to rerun them. Now, what do we end up doing after we find the flaky test is an open question, right? One example here is that let's rerun them, in which case you've said like we cannot rerun them. Another one would be to sort of find an adaptive subset of flaky tests that keep running throughout the day so that the feedback time for developers is reduced while you have another run that's catching flaky tests. So that's something that we are thinking through. We don't quite have an answer today.
Okay. The next one is, what about software that is written in different C-like languages? Are you able to analyze these languages, or is this limited to Java?
No, the car company example that I talked about is using C underneath it, is using sort of Linux for embedded environments. I think it's Yocto Linux. So as I said, our thing is fairly tech stack agnostic. Now, one of the things why we actually have this product advisor program is the developer space is pretty huge. So we are using this as an opportunity to prioritize the right things to build. So if you're working with us on a particular environment that's somewhat esoteric, then we work through it, we build the integration for it, and we should have the results for you.
Okay. This next one is asking us to share the slides, but it's an anonymous attendee. So to whomever asked that question, if you'd like to email us, I can provide the slide deck. We will also be sharing a recording of this webinar. The one after that is, how well does your tool perform in terms of detecting test transitions? Example given, fail to pass, rather than only detecting test failures. I would be interested in knowing whether a test is fixed again.
Let's see. I don't quite know actually how to parse this question. So I'm going to take this offline and, perhaps that's the answer coming in. As we send the slides out, I'll put the answer in. But the way I think about this is you have changes that come in, you run the test pass or fail, and the next time they pass or fail, the model actually learns that, right? That's part and parcel of the system. Now, whether these tests are passing again for that individual run, that from overarching model perspective might be somewhat interesting, but not required. Your developer would know whether the test runs. So let me come back to this on this.
Okay. The next one is, would you use my CI VCS data to train ML models for other customers?
Great question. So today the models are custom to our customers, but the idea for us would be that one of the hypotheses is that there are certain sets of problems that are fairly similar. So if we take the example of, say, Java, right? The Java file changes and the way things get built in Java are somewhat similar, right? And if you're able to sort of learn on, say, a Java model and bring in results earlier to other customers, that's the direction we would head towards. Today, we don't do it, but in the longer term, I think we would.
Okay.
But again, just to call this out, I think the hidden fear here is like, is your data, what's being shared about your data. So the way we think about this is we are converting the data into higher level numbers, which are somewhat meaningless, except for passing these trends to us.
Next question is, which build environments other than Maven do you support?
So I've talked about this, right? So this customer, that the example that we took had Bazel in there. So it's beyond Maven. I talked about the C environment on Linux. We're talking to people who have Node and Node.js. They have Cypress in there, I think. So we're talking to a number of these environments. So again, if you have like a specific environment that you need to sort of think about, reach out to us. More or less, if it's not in our existing set, we'll build that. If not, if it's in the existing set, the path is easier.
Okay, and you sort of answered this next one, but it was, will this work with AWS code build? I'm using Node.js and Cypress. Does it support the combination?
Yeah, I don't see a reason why not. So as I said, we're talking to somebody who has Node.js.
Okay, next one is, can we use it for COBOL?
That's a great question. I do not see a reason why we cannot. We don't have anybody in the product advisor program, so would love to talk to you to see if there are any specific things that actually get in the way of solving for it.
Okay, and the next one is not a question, but it's a link that was shared by the anonymous attendee who said, regarding test transitions, Google reports this to be a critical issue. So that's something we can look into.
All right. Okay. All right. Thank you very much for being on the call. Really appreciate you staying back and asking these questions. We'll send the slides over in a follow-up email. Thank you.
Thanks, everyone.